All right, this is learning curve theory, and let's take a look at this example. We just need to see an illustration of the actual learning curve formula, which is here. You can see the learning curve formula, y equals to ax raised to the x power of b, where y is the cumulative average time, x is the cumulative units of output, and then a equals to time taken to produce the first unit, while b is the cumulative is the learning index or learning coefficient. And you also have to note one thing. You know, some units are produced in batches, and a batch can contain 40 units, 80 units, 50 units, whatever. So when dealing with learning curve, it doesn't matter whether you're producing units in batches or in units. Producing a batch of 40 units and producing a single unit separately have the same learning effect. So when you're given batches, do not convert the batches into units. I hope you got that. Okay, so we are told that the first unit took 100 hours to complete, and the learning rate is 80%. Illustrate the effect of learning curve. So we have this information: A equals to 100 hours, time for the first unit, learning rate equals to 80%, which equals to 0.8. Okay, so we have the units of output here. Let's say we have 1 unit. If it doubles, we have 2 units. Double to 4, double to 8. Ignore this 3 here. Ignore it first. Okay, so as per the formula, we need to know the cumulative average time. Now, how do you determine the cumulative average time? When units double, we do not really need to use this formula here, right? So when units double, just do it this way. Cumulative average time, whenever the units of output double, for the first unit took 100 hours, so no problem. So when you produce 2 units, you would have the average of, we said that 1 to 2 actually that we only have 1 jump, because if 1 doubles, it gets to 2. So you just take 100, the previous one, you multiply by the learning rate, which is 0.8, and you would have 80 here. So this should be the average of 2 units, right? Just like that. Okay, when 2 units double, you get 4 units. So you go previously, you had 80, you take 80 and you multiply by the learning rate again, and you had 64. And then when 4 units double, they double to 8. So you take 64, you multiply by 0.8, which is the learning rate, and you have 51.2. So that's how we apply it. Of course, we did not use the formula, we just use the normal principle since units are doubling here. All right, now you could be told, let's say, I need the time for the first unit, for the second unit, for the third unit. How do you determine that? So do that, we'll have to proceed. So we have the average time already, cumulative average time. So how do you determine the cumulative total time now? Simply speaking, you take average time, because every time is on a per unit basis. You take average time per unit, you multiply by the total number of units. So average time for first unit is 100, total units is 1. 1 times 100, you would have 100 there. Here you take 80 times 2, you'd have 160 total hours for 2 units. And then disregard this number 3 first. For 4 units, I would take 4 units times average for 4 units. 4 times 64, which is 256. And for 8 units, I would take 8 times 51.2, which is 409.6. Something like this, right? And then here we'd have time for the nth unit. We'd have time for the nth unit here. How do we determine that? Now this is, we only have 1 unit as it is. So it's obviously time for the first unit is 100. Now, how do you determine the time for the second unit? Time for the second unit would take time for 2 units minus time for the first unit. So I would have 160 here minus 100, and I would get 60. So if you need time for the second unit, you would have 60 as your value. Now, time for the third unit would be total time for 3 units minus total time for 2 units. Now, we have total time for 2 units of 160, but unfortunately, we do not have total time for 3 units. And this is where the general formula comes into play, y equals to ax power b. So how do we get that? The formula says y equals to ax power b. Now let's first determine our b, which is the learning index. So we'd say logarithm of learning rate of logarithm of 2, but the learning rate was 80%, which is 0.8. So logarithm of 0.8 of logarithm of 2, which gives you negative 0.3219. right? Actually, we have a lot of decimal places, but we can just leave them to 4 decimal places or 5. This is what is mostly done, right? Okay, so you have your B now, all right, and then we need the cumulative average time, which is Y. So how we determine Y? As we said earlier, Y equals to AX power B. So cumulative average time for first 3 units would be equal to A, which is A time for first unit 100 times X. Total units, we have 3 units here, right? So times 3 power B, which is negative 0.3219. So if we plug that into the calculator, we arrive at 70.21 hours. So this should be the cumulative average time for 3 units. This one, 70.21, right? You'd have this value here. All right, so cumulative total time for 3 units would take the average time for 3 units times 3. So 3 times 70.21, you would have 210.63. So now you are very much comfortable in order to obtain the time for the third unit. You just take time for total units, which is total 3 units, then minus time for 2 units, cumulative total time for 2 units. So 210 minus 160, I would arrive at 50.63, right? If you need time for the fourth unit, you take total time for 4 units, which is 256, minus total time for 3 units, which is 210.63, and would arrive at this value. I think this is enough illustration. If you need it for fifth unit, we'll proceed that way. But I hope you have got something here. We said that as time goes further, time labor takes for each additional unit actually gets lowered. And they'll see, oh, time cumulative average time was getting lowered. By that, it meant that time for each consecutive unit was also getting lowered. And you can see here, the first unit took 100 hours, the second unit, 60 hours, the third unit, 50.563 hours, the fourth, 45.37, and so on and so on. So this is what should be the situation, right? Yeah, so this is what was the situation. All right, you can subscribe for regular updates, and thank you very much. And then until next time.